If you want to stand out in AI engineering or agent-focused roles, one skill matters more than most people realize: handling LLM hallucinations. It's not just about knowing that models can be wrong. It's about designing systems that detect, reduce, and recover from those failures. Teams hire for that kind of reliability because turning unpredictable model behavior into dependable product performance is a real career advantage. This matters right now because hallucination isn't just a model quirk. It's become a real hiring filter. Teams building copilots, support agents, and workflow automations need engineers who can make AI behavior reliable, measurable, and safe in production. That's why companies like OpenAI, Google Cloud, Pinecone, NVIDIA, and Lang Smith treat hallucination reduction as core engineering. The difference is simple: not just noticing failures, but showing how you measured them and reduced them. The core issue is that hallucination isn't really a bug you can just patch out. It's structural to how these models work. OpenAI's point is that because the system is trained to predict the next likely word, it will always produce something that sounds plausible, even when it's wrong. That's why employers increasingly value people who can think in systems and understand the limits behind the output. There are 4 common failure modes to watch for. First, unsupported generation, where the model states things that aren't grounded in its training or retrieved evidence. Second, outdated knowledge, when recent changes or events fall beyond the training cutoff. Third, poor retrieval grounding, where weak context causes the model to fill in gaps. And fourth, instruction following errors, when it ignores constraints or scope. In practice, most hallucinations come from context, retrieval, or verification breakdowns. This slide shows the basic RAG flow and how it grounds a model. A user asks a question, that query is embedded, and the system retrieves the most relevant information from a knowledge source. Those retrieved facts are then added to the prompt before the model generates a response. As both Google Cloud and Pinecone describe it, RAG is a primary grounding technique because it brings in real context at inference time and helps reduce fabricated answers. Here's the key insight: grounding alone doesn't eliminate hallucinations. Retrieval quality depends on several design choices, like how you chunk content, which embedding model you use, and whether you re-rank results before building the prompt. Even then, weak or irrelevant context can still slip through. That's why tools like Langsmith and NVIDIA NeMo guardrails emphasize post-generation checks, including faithfulness and hallucination evaluation, as a necessary part of a reliable RAG pipeline. This slide maps out who needs to know what across the team. AI engineers focus on building and evaluating RAG and agent pipelines, especially retrieval quality and eval tooling. AI product defines reliability metrics, failure categories, and launch criteria. Applied scientists go deeper on benchmark design, model behavior, and automated evaluation. And across agent roles, we watch for common failures like wrong tool use, fabricated citations, invalid actions, and overconfident execution. Evaluation has to be treated as a first-class skill. That means defining clear criteria and failure rules, building labeled test sets, running automated evaluators, and inspecting false positives and false negatives. It also means tracking trade-offs like reliability, latency, and cost. OpenAI, Langsmith, and NVIDIA all point to the same conclusion. If you can't measure hallucination repeatably, you can't credibly say you've reduced it. Here are 4 practical ways to evaluate model outputs. Human evaluation is best for nuanced cases where judgment matters. Heuristic checks use simple rules to verify things like format, scope, or whether citations are present. Pairwise comparison asks which of 2 outputs is more faithful, which works well at scale. And with LLM as judge, one model scores another for issues like hallucination. Langsmith covers all 4, and OpenAI's cookbook shows a concrete hallucination example. When evaluating a RAG system, accuracy alone isn't enough. We also need to measure faithfulness, whether the answer is actually supported by the retrieved context. Abstention rate tells us how often the system appropriately says, "I don't know," when evidence is weak, while answer rate shows overall coverage. And of course, latency and cost matter too. NVIDIA NeMo helps track all of this together, including policy, compliance, response time, and token usage. For portfolio projects, don't just build a chatbot. Build something that shows rigor. An internal docs assistant can demonstrate retrieval transparency, citations, and knowing when to abstain. A customer support agent can route between retrieval tools and fallback while logging weak claims for review. Or build a guardrailed workflow agent with approved tools and evidence thresholds. The real hiring signal isn't the UI. It's the evaluation, error analysis, and measurable improvement. Here's the tools landscape we're using as the standard toolchain. Langsmith helps with tracing, evaluation, and debugging, especially for RAG systems and agents, so we can see what the system is actually doing. NVIDIA NeMo Guardrails adds programmable policy controls and helps measure hallucinations. And vector databases are the foundation for retrieval quality. It's important to understand their failure modes, not just compare vendor names. Here are a few common retrieval failure modes I'd call out in interviews. First, chunk size. If chunks are too large, you lose precision. Too small, and you lose important context. Second, stale documents, where outdated content stays in the vector store longer than it should. Third, low confidence retrieval, because a high similarity score doesn't always mean true relevance. And finally, citation validation failures, where the cited source doesn't actually support the model's answer. This slide shows the guardrails architecture from generation to safe output. First, the model generates an initial answer. Then we check faithfulness, making sure the response matches the provided context and stays accurate. Next, we apply policy rules to enforce scope, format, and approved tool use. Finally, the system either returns the answer or abstains. In NVIDIA NeMo Guardrails, these controls are programmable policies built in before a response is delivered. Here are 5 interview questions worth preparing for. You should be ready to explain how you'd measure hallucination in a domain assistant and how to tell whether a bad answer came from retrieval or generation. You may also be asked when human review is better than using an LLM as judge, how to trade off reliability with latency and cost, and which production metrics matter beyond simple accuracy. Here's a strong example of how to answer this well in an interview. Instead of staying abstract, it frames the problem operationally. Define a faithfulness metric around whether claims are actually supported by retrieved context, and pair that with answer and abstention rates. Then focus on failure cases, especially confident answers without evidence. Trace the retrieval path and adjust thresholds. That's the kind of production-minded thinking reflected in approaches from OpenAI, Langsmith, and NVIDIA. When you talk about evaluation, be explicit about the trade-offs. Better grounding usually improves faithfulness, but it also adds latency and cost. Stricter guardrails can make systems safer, but they may reduce answer rate. Automated judges help you scale evaluation, but they still need calibration against human labels. The strongest candidates don't chase perfection. They explain these trade-offs with evidence and focus on shipping something reliably. The key takeaway here is that human skills still matters. Anthropic's transparency reporting found that researchers don't believe AI can fully replace even a junior ML researcher or engineer. That's because companies still need people to design evaluation loops, debug retrieval systems, set reliability policies, and make judgment calls about risk. In other words, the advantage isn't just using AI tools, it's knowing how to guide, evaluate, and trust them responsibly. Here's your action plan for standing out. First, learn grounding and retrieval-augmented generation using resources like Pinecone and Google Cloud architecture docs. Next, master evaluation design with tools such as Langsmith, LLM as judge methods, and faithfulness metrics. Then add guardrails and abstention using NVIDIA NeMo policy rules and confidence thresholds. Finally, build a documented project that shows before and after reliability, error analysis, and a clear, credible methodology. The winning frame here is simple. Hallucination expertise is really reliability expertise. Strong candidates don't just point out that models can hallucinate. They show they know how to detect failures, reduce them, measure performance, and clearly communicate the remaining risk. That's what makes the work actionable for a product team. The person who stands out is the one who can turn model uncertainty into something a team can actually ship with confidence.